Hi guys, welcome to another episode of Learn with Sir Glenn, and for this video, we're going to discuss permutation. So, let's go! Before we proceed with the topic, let's have this problem. So, how many ways can you arrange the letters A, B, and C using all letters? Since you want to arrange the letters A, B, and C using all letters, so we can actually answer this one using the fundamental counting principle, where we're going to have selections and we're going to list down the choices per selection. So for this one, 3 selections. Then for the first selection, we will have 3 for the choices. For the second, we will have 2. Then we will have 1. So multiplying the numbers will give you 6. So therefore, we're going to have 6 arrangements. We're going to arrange the letters A, B, and C using all 3 letters. So those arrangements are ABC, ACB, BAC, BCA, CAB, and CBA. Aside from fundamental counting principle and listing down the arrangements that we can have on our problem, we can also use permutation to solve this kind of problem. So what is permutation? Permutation is an arrangement of n objects taken r at a time with no repetition, and the order is important. So the permutation is also counting outcomes of an experiment, where your experiment should be an arrangement of n objects taken r at a time, and the repetition of objects not allowed, and order of objects is important. Just like our example a while ago. How many ways can you arrange the letters A, B, and C using all the letters? So since we're arranging objects which are A, B, and C, and when we arrange these objects, the repetition is not allowed, the order of object is important, then we will have this example as permutation. So notice that when you list down all the possible arrangements, when you interchange position of 2 letters, you will have 2 different arrangements on our list of arrangements. So just like ABC is different from ACB. These are the conditions for you to have a permutation. So again, so you have to arrange objects with no repetition, and order is important. So how do we solve permutation? The permutation, which is normally denoted by NPR or sometimes P quantity N R, read as N permutation R, or the permutation of N objects taken R at a time, where N is the number of objects to choose from and R is the number of objects to be arranged, is equal to N factorial over quantity N minus R factorial. So whenever you solve for permutation, you're just going to use the formula N factorial over quantity N minus R factorial. So for example, you have 5P4 or 5 permutation 4, or arrangement of 5 objects taken 4 at a time. So using our formula, we will have NPR is equal to N factorial over quantity N minus R factorial. And our given N is equal to 5 and R is equal to 4. So therefore, on our formula, we're going to replace N with 5 and R with 4. And that will give us 5P4 is equal to 5 factorial over quantity 5 minus 4 factorial. Then solving for this one, we have to follow PEMDAS rule. So we're going to work on the parenthesis first, or grouping symbol. So therefore, we will have 5 factorial over 1 factorial. Then simplifying this will give you 5 times 4 times 3 times 2 times 1 over 1 factorial. Cancel 1 over 1, or you can just simply remove it. Then we will have 120. So if you evaluate 5P4, you will have 120. Okay, so let's have another example. So let's say we have 6P6. So again, using the formula, we will have NPR is equal to N factorial over N minus R factorial. Then after this, we're going to replace the N with 6 and R with 6. So that will give us 6 factorial over 6 minus 6 factorial. And solving for this, we will have 6 factorial over 0 factorial. And we all know that 0 factorial is equal to 1. So therefore, we will have 6 times 5 times 4 times 3 times 2 times 1 over 1. Then we will have 720. Okay, so let's have another example. So 9P2. So using the formula, NPR is equal to N factorial over N minus R factorial, where N is equal to 9 and R is equal to 2. Then we will have 9 factorial over quantity 9 minus 2 factorial. So subtracting 9 minus 2 will give you 7. So therefore, we will have 9 factorial over 7 factorial. Then on my previous video, we discussed recurrence relation. So we're going to expand 9 factorial up to 7 factorial. That will give us 9 times 8 times 7 factorial over 7 factorial. So we do this so that we can cancel 7 factorial on the numerator and 7 factorial on denominator. And that will leave us with 9 times 8, which is equal to 72. Okay, so let's have another example. So 8p0. So we will have n factorial over quantity n minus r factorial, replacing n with 8 and r with 0. So we will have 8 factorial over 8 minus 0 factorial. Then we will have 8 factorial over 8 factorial, which is equal to 1. Okay, so let's have another one. So 8p3. So using the formula npr is equal to n factorial over n minus r factorial, we're going to replace the n with 8 and r with 3. So that will give us 8 factorial over quantity 8 minus 3 factorial, which is 8 factorial over 5 factorial. Using recurrence relation on your factorial, we will expand 8 factorial up to 5 factorial, and that will give us 8 times 7 times 6 times 5 factorial. So we do this so that we can cancel the 5 factorial on the numerator and the 5 factorial on the denominator. And we will have 8 times 7 times 6 as our remaining numbers. So multiplying these numbers will give you 336. Okay, so now let's use the permutation in solving word problems. So how many ways can you arrange the letters A, B, and C? So we already solved this one using fundamental counting principle and listing method, but this time we're going to try to solve it using the permutation formula and see if we will have the same answer. So when you solve problems involving permutation, the first thing you're going to do is to identify the n, which is the number of objects we're going to choose from, and the r, which is the number of objects we're going to choose from n to arrange. So for this one, since we're going to choose from the letters A, B, and C, our n is equal to 3. So those are the letters A, B, and C. Since we're going to use all the letters to arrange, our r is equal to 3. So using the formula n factorial over quantity n minus r factorial, we're going to replace the n with 3 and r with 3. And that will give us 3p3 is equal to 3 factorial over 3 minus 3 factorial. Solving for this, we will have 3p3 is equal to 3 factorial over 0 factorial, and we all know that 0 factorial is equal to 1, and that will give us 3 times 2 times 1 over 1, which is equal to 6. So whether you use the fundamental counting principle, listing method, or the formula for the permutation, we will have the same answer, which is 6 arrangements. Okay, so now let's try it on a different problem. So how many ways can you arrange A, B, C, D, and E taken 3 letters at a time? So again, first thing that you're going to do is to identify the n and the r. So the n is the number of objects we're going to choose from, and r is the number of objects we're going to take from n to arrange. So therefore, on this example, we have our n equals 5 because we're going to use the letters A, B, C, D, and E. And from 5 objects, we're going to take 3 letters to arrange. So r is equal to 3. Using our formula, npr is equal to n factorial over n minus r factorial, we're going to replace the n with 5 and r with 3. So therefore, we will have 5 factorial over 5 minus 3 factorial, and that will give us 5 factorial over 2 factorial. Using recurrence relation for factorial, we will expand 5 factorial up to 2 factorial, and that will give us 5 times 4 times 3 times 2 factorial over 2 factorial. Then from here, we can now cancel 2 factorial on the numerator and 2 factorial on the denominator, leaving us with 5 times 4 times 3, which is equal to 60. So therefore, if we're going to arrange 5 objects, taken 3 objects at a time, we will have 60 arrangements. Okay, so let's have another example. In a class with 4 boys and 6 girls, how many ways can a teacher choose his president, vice president, and secretary? Although on this problem, there is no word arrangement or arrange, since we have here position like president, vice president, and secretary, then the order of objects is still important. So therefore, this is still under permutation. And to solve for this using the permutation formula, we have to identify the n and the r. The n will be 10 because we're going to choose from 10 students, which are 4 boys and 6 girls. Then the r is 3 because we're going to choose 3 positions which are the president, vice president, and secretary. Using our permutation, we will have NPR is equal to n factorial over n minus r factorial, where n is equal to 10 and r is equal to 3. So replacing n and r with the given values, we will have 10p3 is equal to 10 factorial over quantity 10 minus 3 factorial. And that will give us 10 factorial over 7 factorial. We're going to expand 10 factorial up to 7 factorial, and that will give us 10 times 9 times 8 times 7 factorial. We do that so that we can cancel 7 factorial, leaving us with 10 times 9 times 8, which is equal to 720. So the teacher will have 720 arrangements of president, vice president, secretary with 10 students. Okay, so let's have another example. So how many ways can the letters of word beauty be arranged? So therefore, we will have permutation because of the word arrangement. First, we have to identify the N and the R. So for this one, your N is composed of the letters from the word beauty. So therefore, we will have 6 because there are 6 letters. And the R, since we're going to use all the letters of the word beauty, we will have R is also equal to 6. Using our formula, NPR is equal to n factorial over n minus r factorial, we will have 6 factorial over quantity 6 minus 6 factorial. So solving for this, we will have 6 factorial over 0 factorial, and we all know that 0 factorial is equal to 1. So therefore, we will have 6 times 5 times 4 times 3 times 2 times 1 over 1, which will give us 720. So if we're going to rearrange the letters of the word beauty, we will have 720 different arrangements. Okay, so let's have another example. So how many ways can the letters of the word beauty be arranged if the first letter must be Y? This is almost the same with the previous example, except that this time we are given a condition. So we're going to arrange the letters of the word beauty, but the first letter must be Y. So if we're solving for a permutation problem with a given condition, the first thing you're going to do is to satisfy the condition. To satisfy the condition, since we're going to arrange 6 letters, and the first letter must be Y, on the first letter of those 6 letters, on the first letter of our arrangements, we're going to put the Y. So if we're going to put Y on the first letter of our arrangements, then we will only have to arrange the remaining 5 letters. So those remaining 5 letters are the B, E, A, U, T. So therefore, we're going to have the permutation only on those 5 remaining letters. So if we're going to get the N will be only 5 letters, so therefore n is equal to 5, because we're going to choose only from the letters B, E, A, U, T. Removing the Y from the choices because we already put the Y on the first letter of our arrangements. Then the R is equal to 5 because we only have to rearrange the remaining 5 letters. Then using our permutation formula, NPR is equal to n factorial over n minus r factorial. We will have 5 factorial over quantity 5 minus 5 factorial, and that will give us 5 factorial over 0 factorial, which is equal to 5 times 4 times 3 times 2 times 1 all over 1. And when you multiply this, you will have 120 arrangements. So if we're going to arrange the letters of the word beauty using all the letters, you will have 720 arrangements. From those 720 arrangements, 120 arrangements will start with Y. Okay, so that's it. Thank you for watching and hope you have learned something from this video.